Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Syamim. Okay, today I would like to present um, group assignment 2. Okay, the title is Analysis of Basic DC Motor Equivalent Circuit. Okay, for the objective of this experiment is to familiarize with the fundamental electrical electronic engineering software. For the second objective is to analyze DC motor equivalent circuit using electronic engineering software. Okay, for the scenario is as a factory maintenance engineer, we are required to propose a suitable DC motor to operate a conveyor belt used in production section. An analysis report is required for that purpose. Okay. Given that DC motor has the following parameters. For the field resistance, 110 ohm. For the armature resistance, 0.3 ohm. Okay, for the DC voltage source is 150 volt. Okay, for the part A simulation task 1, the DC motor is connected in shunt configuration. Simulate the circuit using an electrical electronic engineering software. So this is the simulation. The software that I use for this experiment is Proteus. Okay, this is the voltage source 150 volt. After that, the field resistance, we use the resistor 110 ohm, and this is the armature resistance. So this is the result that I got. We got 4.42. Okay. After that, for the second, I show the connection of the probe meter in measuring all voltage and currents in the circuit. So this is the second simulation. Okay, this is the power source, and I using the resistor, and so the data that I got is the volt is 150 volt, the current is 1.36 ampere, and the kilo RPM is 4.37. Okay, for the task 2, we need the DC motor in the series configuration. So I do the same software purchase and using the same data, and then I got the RPM is 0.15. And for the second part is we need to show the connection probe is measuring all the voltage current in the circuit. So this is the data that I got. For the voltage is 0.74 volt, the current is 1.36 ampere. Okay, for the kilo RPM is 0.14. Okay, after we finish the part A, so the part B we need to do the data analysis. So an experiment. So for the first table is about separately excited DC motor. So like other what is separately excited DC motor? This motor also have stator and rotor. Stator refer to the static part of the motor, which consists of field winding, and rotor is the moving armature, which contain armature winding or coil. So separately excited DC motor has field coil similar to that of the shunt wound DC motor. The name suggests the construction of this type of motor is usually in other DC motor. So the field coil and armature coil both are energized for the single source. The field them does not need any separate excitation. Okay, for the separately excited DC motor used in for the application is we use this DC generator in laboratory for testing, as they have a wide range of voltage input. Used as supply for DC motor. Okay, for the series DC motor, the series wound DC motor is like in case of shunt, wound DC motor or compound wound DC motor. They're divided into two. So um, they fall under the category of self-excited DC motor. So it gets the name from the fact that field winding in this case is connected internally in series to the armature winding. Thus, the field winding are exposed to the entire armature current, unlike in the case of shunt motor. The series DC motor are used where high starting torque is required and variation in speed are possible.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Nazirul Aiman bin Mahadi, and today I will explain about the analysis of basic DC motor equivalent circuit. So for my part, I will explain about the analysis of table 3 and 4. So before that, we go through from circuit by circuit. So for the task 1, the DC motor connect in shunt configuration. So for the circuit, we can see right here the connections of the DC motor in shunt circuit. So we can see right here the voltage is 150 and the current is 1.36 ampere and the motor rotation is 4.37. So for the task 2, the DC motor is now connect in series configuration. Right here we can see the circuit designed by me and my friend. So we can see the difference in voltage because the connection is in series, so the voltage is 0.74 volt, then the current is 1.36 ampere, for the motor rotation is 0.14. So for the table 3, which is shunt DC motor, we can see right here motor armature voltage, motor armature current, motor field current, motor rotation speed in RPM, and motor torque. So we can see the motor armature voltage is equivalent for the value which is 264. The motor armature current is increased from 0.226 to 1.686. For the motor field, the value is same 0.210. For motor rotation, it decreased from 1490 to 1280. So for the motor torque is increased from 0.34 to 2.34. So we can see right here the motor armature is increased from 0.226 until 1.686, and the motor rotation will increase uh, from will decrease from 1490 to 1280. When the motor rotation speed is decreased, the motor torque will increase. So we can see right here the value of the motor torque is 0.34 to 2.34. So a DC shunt motor, also known this shunt wound DC motor, is the type of self-excited DC motor where the field winding are shunt or are connect in parallel to armature winding motor. Since they are connect in parallel, the armature and field winding are exposed to the same supply voltage. The shunt motor are used where constant speed is required and start conditions are not served. The various applications of DC shunt motor are in lathe machine, centrifugal pump, fans, blower, conveyor, lift, weaving machine, spinning machine, and so on. Okay, for the table 4, which is cumulative compound DC motor, the motor armature value still same 264. The motor armature current is increased from 0.213 until 1.192. For the motor field, still same, which is 0.210, and for the motor speed, which decreased from 1399 until 1034. For the motor torque, which increased from 0.33 until 2.32. The analysis and that we can make right here is when the motor armature is increased in value, the motor speed rotation will will decrease, and the motor torque will increase from 0.33 to 2.32. Okay, so in cumulative compound motor, the polarity of the shunt winding is such that it includes to the arrangement area. This shunt winding can be either brief shunt where the shunt is parallel with the armature, or the shunt is in parallel with the both armature and the arrangement field. The shunt winding are tied such as a way to help both armature and series field, creating a aggregate impact. The engine is named the cumulative compound engine, hence suggests the suitable application for each motor based on the characteristic for each of them. In differential compound motor, attractive area of the shunt winding restrict the armature attractive area and the arrangement area. This kind of the differential winding give diverse torque and motor speed characteristic. The shunt field is creating an inverse impact. It is not all like shunt engine. When the stack is diminished, differential compound engine carries on more like arrangement engine and tends to overspeed. When the stack is expanded, the speed is diminished uh, radically. So cumulative compound wound motor are virtually suitable for almost all applications like business machine, machine tool, agitator and mixture, and so on. Compound motor are used to drive load such as shear presses, uh, reciprocating machine. So that's all from me. Thank you.